Good morning. This recording is for Pre-Algebra Chapter 8, Lesson 4, Direct Variation. Direct variation is a linear function, much like y equals mx plus b, where k does not equal 0. K, the coefficient of x, is the constant of variation. And I'll talk about how it relates to something that we talked about earlier in this chapter in just a few minutes. But let's go ahead and focus on k. K is the slope of the line for y equals kx, which can be determined by plugging a point for the line that they give you. You just can't use the point 0, 0. So the table of values below models a direct variation equation. So basically these are a bunch of points that are on a line that you could have gotten from using the equation, or they could just give you. The thing is we want to figure out the constant variation. We want to figure out what the slope is of this line. All right, so you could use the slope formula that I gave you from a previous lesson, or you can just understand the equation y equals kx. All right, so what we can do is we can replace x and y with a point, and in this case I'm going to use 3, 4. So I'm going to replace y. With 4 and x with 3. All right, and then I'm going to solve for k, because k is the direct variation. So I'm going to divide by 3 on both sides, and k equals 4 over 3. And again, the 3's cancel out. All right, so that's the constant of variation for the equation that is modeled by those points. Okay? All right. And why can't we use 0, 0 to determine the constant of variation? Oh, by the way, that's the equation. All right, and again, you could use any of the other points as well, but you're still going to get the same constant of variation each time. Okay, still the same. But why can't we use 0, 0? That's because the constant of variation would always be 0. So that's why we can't use 0, 0. Okay, so the table of values below models a direct variation equation. I'm going to graph the points and find the constant of variation, then write the equation using the constant of variation. So last time they were asking for just the constant of variation. This time we're looking for the equation, all right, which is going to be y equals kx, where k actually equals a number. So I've got my graph. I'm going to graph some points. There they are. And I'm going to figure out the slope of the line. Well, the constant of variation is the slope. And so to find the slope, I'm going to rise 3 and run 2. Rise over run means the constant of variation is 3 over 2. And I could always continue this to get to the next point, too. I could go up 3 to the right 2. Up 3 to the right 2. And so on, right? Makes sense? Awesome, huh? Okay. So again, that is the constant variation. The thing is, though, is that they want the equation of the line, which means I basically just need to replace k in the equation y equals kx with what k equals from my table, which was 3 over 2. Alright, you know what, let's pause that real quick. So again, I'm going to take y equals kx, and I'm going to just replace k with what k equals, 3 over 2. That is the equation, alright? That is the equation of the line that is represented by these points. All right? Okay. So now back to what I was talking about down here. Notice how y equals kx is very similar to y equals mx plus b, where both k and m represent the slope. K and m are basically the same thing. And if you go on later in life, they might actually replace k with m. The only thing is, in y equals kx, there is no b. And that's because b just equals 0 in direct variation. For direct variation, the y-intercept is always going to be 0, 0. But that's only for direct variation. Okay? Variation. Okay, there we go. All right? So they're very similar. And again, in other textbooks and other teachers you have might actually replace k with m, but they mean the exact same thing. Okay, let's move on. So, slope of direct variation is basically just y over x. And you can do that by getting k by itself, because again, k is the slope. All right? So, too far. Okay, so let's talk about word problems and direct variation. When talking about the constant of variation, you say y varies directly with x. Pay attention to this wording when handling word problems, because it's actually going to tell you what values end up being y and which values end up being x. Okay, so if it's y varies directly with x. So something that varies directly with another thing, that first thing would be your y value, and that second thing would be your x value. Okay? So your weight on Earth, which we're going to represent with W, or y, because it varies directly with your weight on Mars. And when we say something varies directly with another thing, the first thing is your y value, the second thing is your x value. Okay, so y is now w, and m is now x. All right, so a person who weighs 120 pounds on Earth weighs about 40 pounds on Mars. We're going to first find the constant of variation and then determine the weight of a person on Mars who weighs 180 pounds on Earth. All right, so again, that's the x value and that's the y value. And W equals Km. So basically you see how it's very similar to those things. And the only reason we're using M here is because M has to do with Mars. It's not slope, so it's very confusing. And maybe I should have used a different letter other than M. Anyway, but M has to do with Mars and W has to do with Earth. Anyway, alright, so let's replace some values so we can figure out K. W was 120. Oh, first we're going to figure out K. That's just writing out the directions. W equals 120 and M equals 40. So let's figure out K by dividing by 40, and K equals 3. That means a constant of variation for how things directly relate on Earth to weight and Mars to weight is 3. There's a difference of 3, or a factor of 3. Okay? So let's go ahead and do the next part, which is to find out how much someone weighs on Mars if they weigh 180 pounds on Earth. So we're now going to use K to write an equation to find out your weight on Mars. So we're going to replace K with 3 and the fact that we weigh 180 pounds on Earth, which was W. So now we need to solve for M. Divide by 3, divide by 3. M equals 60, which means you're going to weigh 60 pounds on Mars if you weigh 180 pounds on Earth. Now let's do the next part. How much does a person weigh who weighs 75 pounds on Mars weigh on Earth? Well, we're still using the same formula and we still have a constant of variation. So we're going to take W, which is the weight on Earth, equals 3 times 75, 75 being the weight on Mars. We're going to find out that somebody who weighs 75 pounds on Mars weighs 225 pounds on Earth. Go figure. Okay. Last thing we need to talk about. You can find the constant of variation using an ordered pair as long as like the question tells you that the ordered pair is on a line that varies directly. Okay, they have to specifically say this only works for direct variation. It's not going to work for a y equals mx plus b equation. Okay, so basically we can just take our direct variation equation. Y equals kx, replace the y with -5 and the x with 3, solve for k, and we're going to get k equals -5/3. Alright, that's constant variation. But they want us to write an equation, so we need to stick the k into the equation, and that's actually the answer. So even though you have to do this work to figure out the answer, you're not done until you actually stick it in the equation, if they're looking for the equation as an answer. If all they're looking for is the constant of variation, that's when you're done. But you're not done if they're asking for the equation. Okay, I'm done. Bye, guys.